Good evening, guys. Am I visible? All right. Okay, very good evening, all of you. So yes, we are going to continue our discussion. And first of all, let me remind you all that you can find me on Unacademy CSI-UGC NET category. You can search my name Jagriti Sharma over here, and I am teaching for CSI-UGC NET, guys. I have myself qualified the exam, and I have been teaching in this category for the last 3 years. All right, I have qualified CSI NET, GATE, and IIT JAM exam as well. All right, and what is going on right now in my profile, you will see I am basically conducting courses on organic plus inorganic chemistry. So what you'll see right now in my profile is detailed course on inorganic chemistry, where we have already completed chemical bonding chapter, and now we are doing coordination chemistry. The course is there in the morning 10:30 a.m. Another course is reactive intermediates. All right, so these are plus courses, and the platform is a paid platform. You have to take the subscription to see these courses. And we are also doing a lot of free classes, which we call the special class. Okay, so once you visit my profile, you will be able to see complete organic reaction mechanism. There are plenty of classes over here. You are just going to register in this class, and you will be able to get timely notifications. So what we are doing in the special classes, we are doing the concept. We are studying the concepts over there. And in the YouTube session, all right, Friday and Sunday YouTube session 6 p.m., we are doing the practice. So last Friday we already had a session, practice on reaction mechanism part 1, and this is our second practice session part 2, okay, on reaction mechanism. Yes, I hope that everyone has joined. Very well, everyone can see and hear me properly also. चलो फिर हम जल्दी से शुरू कर देते हैं practice without any further delay. We in the last session also we had done 7 questions. Okay, yes, let's do a lot of questions, guys. Chalo, let's begin. And I hope that you are noting down everything, whatever you are studying, because the the YouTube sessions and the special class, they go hand in hand. So whatever you see in the special class and the YouTube, you are going to note down in the same notebook. Yes, दोनों topic reaction mechanism topic ही चल रहा है, concept and practice. So side by side, write each and everything. So the first question that we do is, for the following two reactions, for the following two reactions, A and B, for the following two reactions, A and B, find the correct statement, or the correct statement is, the correct statement is. Assignment का last question नहीं हुआ है. Okay, Yogesh, will discuss that in the doubt session then. Plus doubt session. Alright, so there is this molecule. The Br is above the plane. The acid is also above the plane, and the tertiary butyl group as well. All of these groups are above the plane. You are adding a very bulky base, potassium tertiary butoxide, in excess. Okay, what do you get from here? Another substrate, Br. COH went below this time. Tertiary butyl still above. Once again the same base, potassium tertiary butoxide, in excess. What is the major product? Okay, so you have to identify कि अब जो options है, which is the correct option for this question. Let's say we write option number 1, option number A. A gives this molecule, B gives this molecule COOK. K is potassium, tertiary butyl group as it is. Option number B is, you have to write all the options, okay? अगर आप previous year question में देख रहे हो then very well, but if you haven't then please write all the options. Not going to take much time. Class notes बनाते चलो guys. B gives this molecule both A and B give this molecule. Option number D I'm writing here. Both A and B give this molecule COOK wala. Hello Mohit. Hello everyone who has joined. Yes. So this is the first question. Okay, so what is the correct answer? Yes. All right, guys, good. Try to write the whole mechanism. So basically, it's a elimination reaction as you can see. But what is the condition for elimination? Yes, very well. Let's now, yes, I hope that most of you have done this question. Most of you have tried out the answer. इसका answer B है guys. The correct answer is option number B. And this is a question of NET June 2012. Yeah, it's a very old question, but nonetheless, it is very important. And this has been asked from the Claydon solution manual. It is there from the Claydon solution manual. ठीक है? Yes. Hello guys who are joining now, welcome. So yes, let's discuss the question in the other slide. So the compound A looks like this. Br is above, your acid is above, and the tertiary butyl group is above as well. So if you want to draw an isomer, let's say if you want to draw a cyclohexane molecule like this, you will say that tertiary butyl group is above, it should be equatorial. Yes, it is. Then the Br is above, it is axial. The acid group is above, it is going to be equatorial like this. Now this is the most stable conformation of this molecule, right? And in this conformation you see that the hydrogen and the Br, both of these are in the anti-periplanar position, which is the perfect position for the elimination to take place. कोई भी base हो, tertiary butoxide हो, methoxide हो, anyone, what is going to happen? Yeah, there is excess of the base. Excess क्यों चाहिए? Because if you are taking 1 mole of the base is only going to take away the acid proton. ये तो acid है ना? Acid, acidic in nature. So first of all, ये क्या करेगा? COO minus it's going to form. Yes. So 1 mole already used up. So you require the second mole for doing the elimination. Yes. Now the base comes and grabs this proton. Anti-periplenarity के वजह से this is going to give you a product like this. A double bond, Br is removed, COOK, tertiary butyl group, or you can write the molecule like this as well. COOK, K is potassium, carboxylate salt है. This is what you get. तो ऑप्शन बी में क्या था? ऑप्शन बी में था A gives this product. Right? So it is correct. A is giving this product. It is correct. Yes. What about B option? B में क्या था guys? You just had the acid part below, COOH, like this. Now can I directly say, I can write it in this way, in the chair conformation, the Br is still above. What has changed? What has changed? The acid has now come below. And can I directly write it? COH को मैं directly COO minus लिख सकती हूँ because there is a base. I know it will be deprotonated. I can do that. So the O minus is going to fall off like this and the Br eliminates. Now this time a hydrogen was not there anti-periplanar to Br. Hydrogen नहीं था Br के anti-periplanarity में. Who was there? The carboxylic acid group. And that is why decarboxylation takes place along with the elimination of Br minus. So minus CO2 minus Br minus, this is your major product that you get, tertiary butyl group and a double bond over here. Alright, and you can directly write this molecule in this way. Tertiary butyl group above and this is your double bond. Alright, from the third carbon. So B molecule gives this compound. Right? This is clear to everyone, yes or no? You are not going to get the PDF of this YouTube session, so either take a screenshot or just note it down somewhere. Yes, in special classes you get PDF. यहाँ PDF नहीं मिलेगा. हीट मेंशन नहीं होनी चाहिए डिकार्बोक्सिलेशन के लिए. यस योगेश, यहाँ पे वो नॉर्मल डिकार्बोक्सिलेशन नहीं है. यहाँ पे डिकार्बोक्सिलेशन इज आल्सो ड्रिवन by the elimination of Br minus, so entropically huge favored. Why? एक molecule से तीन molecule मिल रहे हैं. Yes, because this one molecule eliminates to give this alkene along with that CO2 along with that Br minus. Okay, so just in the presence of base this is happening. Yes, Chaudhary. See, मौलिक, yes, 70 marks लाने के लिए कौन सा टॉपिक करना होगा? See, I have already done a session. The first session in the month of April was starting with a strategy. Please see that session. Strategy session है, वहां पे आपको काफी help मिलेगी. Okay? Yes, we start another question quickly. The mechanism involved in the following conversion is, now this is a very plain question but only if you know it. और हर एक सेशन में ये क्वेश्चन मैं एक बार तो करा ही देती हूँ. इससे दो फायदे हैं. ऑल राइट, फर्स्ट यू अंडरस्टैंड द प्रोटेक्शन ग्रुप ऑल्सो and second you understand the mechanism also. So this question is important by two different ways. Yes, what's going on? In the presence of p pyridine, you get this product plus a free amino acid CO2ET. ठीक है, so what is the mechanism? E2 elimination E1 elimination, thin elimination, and E1CB elimination. Yes. So now everyone has learned this molecule, but yes, looking at this once again, just to make sure that you remember. E1CB elimination, वेरी वेल गाइस, बहुत जरूरी है इसको बार बार देखते रहना ताकि हम इसको भूले नहीं, ये बड़ा सा मॉलिक्यूल, अदरवाइज इट विल बी स्कैरी. So what's going on over here? This is your alpha amino acid part. Yes, this is your alpha amino acid over here. और बाकी क्या है? Carbonyl carboxylic acid group over here, and this group that we call this one from the methyl to this 2 benzene, क्या बोलते हैं इसको? Fluorenyl. Yes, right. So what is this F-MOC protecting group? Yes, fluorenyl methyl oxycarbonyl, isn't it? F-MOC protecting group. This is your fluorenyl methyl oxycarbonyl. This is what you get in the F-MOC, and this is the alpha amino acid which is being protected. And what happens is guys, इसको हम कैसे remove करते हैं? How do we remove this? Through the E1CB mechanism in the presence of a piperidine base. Piperidine base is like this. It's not a like very strong base like the methoxide and the ethoxide. Still, weak base is doing the job. Why? What is the reason? कि weak base से ही हमारा काम हो जा रहा है of deprotection. Yes, because a proton from here it will be removed. See, it is a beta elimination reaction. E1 हो, E2 हो, कुछ भी हो, दो अलग अलग carbon से proton and the leaving group is going to leave, right? So let's say we have a carbon over here. ये जो hydrogen है, this is going to leave from this carbon. There is a negative charge over here. Yes, and this system is stable because of aromaticity. So the bond falls up like this. ये निकल गया CO2 from here. Sorry, the arrow is going to go like that in this direction. Okay, so you have this fluorenyl group, the amino acid as well as CO2 eliminated. Okay, so this is through the E1CB mechanism, elimination through conjugate base. All right, easy question. We did a very simple question. ठीक है. Let's move onward to the third one. Once again, major product which is formed. I hope that you are noting down or taking a screenshot for you to remember what you had practiced. And also, if you don't remember any question, if you're not able to solve any question, usko double star mark kar do to revise it later on. Alright, this also is an easy question. Yes, guys, your answers. Okay, name of this reaction. The OH is below, the methyl is below. Yes, to give elimination, xanthate elimination, whichever you want to call it. You can call it Chugave elimination or xanthate elimination, whichever you want to call it, right? What happens is, first of all, you are going to form the xanthate ester. Second step है pyrolysis. Methyl over here, ये दोनों डाइमिथाइल ग्रुप हो गए हैं. Oxygen C double bond S SME. This is your xanthate ester that you get. All right. What is the xanthate ester looking for? It is looking for a same side proton. It is looking for a proton which is on the same side. So on the first carbon, on the topmost carbon, यहाँ पे तो methyl below है and the hydrogen is above. So syn elimination not possible on this side. So ये product हो जाएगा wrong. C is not your answer. ये elimination है और dimerization is absolutely absurd. Okay. So बचा कौन? Option A. So you are just going to write the elimination product like this. This is still your methyl isopropyl. And what happens along with this? क्या मिलेगा byproduct? Byproduct is COS molecule plus MESH, a thiol. Okay, so your answer is option number A. बहुत ही simple question. Let's do a very good question after this one. Yes, चलो fourth question करते हैं. Everyone is clear with this one? Question number 4 is once again the major product. You have tosyl chloride, you have pyridine. What is the major product? Okay, guys. Yes, so what do you think is the correct answer? Try it out. Yes, Lara, I am asking. You're asking me. एक बार गाइज मुझे पता है आपने रीअरेंजमेंट करा दिया. यू आर सक्सेसफुल एट दैट एंड रोटेशन भी करा लिया अच्छे से. वेरी गुड. बट रिकंसिडर वेयर द न्यूक्लियोफाइल विल अटैक. चलो ठीक है, let's solve this question guys. What's happening? अच्छा ठीक है. First of all, you know the OH is going to convert into OTS. Very well. OTS है, OTS निकल जाएगा. There will be a carbocation over here. Now which group is going to migrate? I had said in the previous examples guys, जब ऐसे वाला example होता था, like today itself I had said, when the example was like this, OH2 positive while we were doing elimination, जब ये होता है तो this carbon does not want to migrate because then the ring will be small, isn't it? Then the ring will be small like this. ऐसी ring हो जाएगी. Yes, लेकिन ये तो already small ring है. So now this carbon has to migrate because this is its only way to expand. Yes or no? It can expand like this. Yes, this is clear to you all. Okay, now this part is clear. Now where is the nucleophile going to attack? Now pyridine is not a nucleophile over here. Pyridine is only there to take away this proton. ठीक है? So हम क्या करेंगे guys? OTS is only available, nothing else. So OTS is going to attack where? Onto this carbon, above or below. Definitely there are these two bulky methyl groups. So which is the product which you form? Exo product nahi banega. Because of the two bulky methyl group, the OTS is going to attack from below. This is your endo product more favored. ठीक है? Yes, endo product is more favored over here. So B is your correct answer. Now let's move onwards. Yes, let's move onwards to a very nice question जो हमने class में किया था. In the free special class we did this question. वही exam में कैसे पूछा है देखो. And guys who are not attending the free classes, please do. This is the only time I am providing reaction mechanism free. The whole topic. All right. So this is your question. What is the major product? Let's see the options then. A, B. I'm writing the C and D over here as well. All right. Yes, Gagan, absolutely. Very good. Yes, and what else did I tell you? Look at the stereochemistry of the intermediate. Intermediate का stereochemistry कैसा है? Retention in configuration. Very good. No Shoaib, we are not having a base. ये तो acetic acid है. We're not having a base over here. This is not elimination. This is acetolysis, isn't it? देखो क्या हो रहा है. OTS, ACOH. In the product you are having OAC and you are having a pH over here. Isn't it NGP? इतना identify करो पहले. This is NGP, right? Yes, Gagan, very good. Yes, it is NGP. So the phenyl group is going to, and the molecule, this molecule is drawn in a proper format also. कब आया ये question? June 2014 में. June 2014 CSIR net exam, and the molecule is drawn in a very nice conformation. आजकल ऐसा बताते नहीं है, ऐसे draw करके भी नहीं देते हैं. They are like, why to make things obvious? Alright, so take care of this. This methyl is above and the hydrogen is above over here. ऐसे याद इसको ध्यान रखना. Now you are getting a phenonium ion like this. We had done this in the class. ये phenonium ion है. What is the stereochemistry of phenonium ion? C2 axis या sigma plane? Sigma plane, yes. You have a sigma plane or you have a C2 axis. The hydrogen and the methyl, they are above. क्या मिलेगा? You have a C2 axis, isn't it? You have a C2 axis over here. Yes, C2 axis बन गया यहाँ पे, तो क्या चाहिए फिर? C2 axis is going to give you homomers. Where? Either the acetate or let's say the acetic acid, if it attacks over here or if it attacks over here, दोनों product same मिलेंगे, identical product. तो कहीं से भी खोल दो, एक ही बात है. Alright, so let's say we open it from this side so that comparing with the molecule will be easier क्योंकि यहीं से हमारा OTS निकला था. So let's consider this one. Let's not consider this example, this side. ठीक है? It will be easier to compare, that's why. ये आ गया pH. Let the methyl and hydrogen be as it is. Now below you are going to have your acetate group. Methyl goes above and hydrogen इस तरीके से below आ गया. So your answer is option number A. This is NGP and this is your answer, which is going to be one single product by both the sides. Okay? Yes, very good. One product. Okay. हो गया? Let's move onwards. All right, let's see this. Question number 6. Once again, the major product which is formed in this reaction is cyclooctadiene molecule. First step, phenyl selenium chloride. Second step, okay, phenyl selenium chloride in the presence of चलो ठीक है, ऐसे ऐड कर देते हैं ACOH and NaOAC in the second step. ठीक है. Third step में we are adding H2O2 in the presence of methanol. All right, and the options are थोड़ा सा डिफरेंट है. ट्राई दिस आउट. ओके. Yes, everyone. What's the correct answer? नहीं होगा या हो गया है? Yes, is it that difficult? कुछ लोग तो चले भी गए क्लास छोड़ के. गाइस, इतना मुश्किल क्वेश्चन है क्या? चलो ठीक है. So let's do this. See, what can you do first of all? Yes, first of all, yes, selenium is behaving as an electrophile over here. पता चल गया because double bond है, right? Let's say on this carbon I have added SEPH ऐसा करके, and the other carbon is having a positive charge over here, right? Now what happens is the double bond is going to attack on this positive charge, yes. And which ring will it give? अब देखो, most probable thing is कि 5 membered ring देगा, because that will be like more favored. 1 2 3 4 5 यहाँ से और यहाँ से connect करो. This is going to give you a 5 membered ring. All right. SEPH. This was the carbon. These two carbons. यहाँ पे positive charge है. Okay. So there is a positive charge over here. Second step में क्या हो रहा है? There is just acetate over here, right? So acetic acid, acetate, you just got a nucleophile. All right. Second step मत लिखो इसको directly यही step लिख दो comma देके, because now in the same step you got this acetate or acetic acid nucleophile over here. It's going to attack. What will you get? Let's say you got two 5 membered rings. See, ये आ गया acetate इधर. Let's say I'm not mentioning any stereochemistry as of now. So tell me this one thing. 5 membered ring जो होती है, these are too small to do these hydrogens in the opposite direction. Yes or no? 5 membered ring would favor a cis junction. Smaller the ring, more favorable is the cis junction. Yes or no? Which means both the hydrogens will be on the same side. Let's take both of the hydrogens above the plane. ठीक है? Let's take both of the hydrogens above the plane. ये आ गया SEPH over here. This is your acetate over here. All right. Third step में क्या है? Heteroatom oxidation. What is there in the third step? Heteroatom oxidation. Now, yes, guys. Now what do you get? देखो, you have formed a formed two 5-membered rings from over here, right? Now the heteroatom oxidation will make sure ये इस तरीके से हमारे पास ये आ गया, let's say O minus. What is it going to do? It's going to cause the sulfur oxide elimination. Yes, it is causing sulfur oxide elimination like this. Now, if you have noticed one thing, answer is option number D. If you have noticed one thing, कि ये molecule जो है option number C, why is it wrong? It is wrong because in the sulfur oxide elimination H2O2 methanol का जो combination है, today only in the class I had mentioned guys 10 degree centigrade, yes or no? ये मेंशन करा था कहीं पे 10 डिग्री है, कहीं पे 0 डिग्री है. यस, आई हैड मेंशन दैट. हाँ, राइट. मतलब कि फॉर दिस रिएजेंट टू कॉज द सल्फर ऑक्साइड एलिमिनेशन वी डोंट वांट अ वेरी हाई टेम्परेचर, जरूरत ही नहीं है. यस, यस, राइट. लेकिन अगर ये डबल बॉन्ड बनता, कैसे बनता? एसिटेट पायरोलाइसिस, यस और नो? ट्रू एसिटेट पायरोलाइसिस विच रिक्वायर्स अ सिन हाइड्रोजन. ये हाइड्रोजन सिन में नहीं जाएगा, ये ऑपोजिट में जाएगा. एनीवेज, that high temperature is not provided, so acetate pyrolysis is not taking place. That is why you don't get a double bond over here. Okay, it's only sulfur oxide elimination taking place at 10 degrees centigrade. D is your correct answer. All right, तो ये हमारा आंसर हो गया ऑप्शन नंबर डी. ओके, इजी क्वेश्चंस, बहुत ही ज्यादा इंटरेस्टिंग क्वेश्चंस थे गाइस. लेट्स डू एन इजी वन नाउ. एकदम इजी सा क्वेश्चन कर लेते हैं, चलो. Question number 7. This is going to be our last question for today. All right. Will the reaction occur at 0 degree centigrade? Yes, Kartika. The reaction will occur at 0 to 10 degree centigrade. इसीलिए we don't provide heat over there. N dodecane and heat. All right. So what is your correct option? Let me write all the options for you. बहुत simple सा question है guys ये. By now everyone must know this. All right. N dodecane is just a solvent. ये तो सिर्फ एक solvent है. You are providing heat over here. Okay, so what is your correct answer, guys? Very well, Rituja, Anusha. Very well, guys. Very well, guys. Yes. बहुत ही simple question है. Once again, to give elimination. Once again, to give elimination. This is what we have done several times. और अब तो ये बहुत easy हो गया है. Just convert this OH to your xanthate group and look for a syn hydrogen. Yes or no? Convert the OH into a xanthate group और same side का जो hydrogen है उसके लिए search करो. So here you are having the सेम साइड हाइड्रोजन इधर क्या है? This is a hydrogen which is below the plane, so we are definitely not eliminating from this side, right? मतलब कि this option is wrong. This option is wrong. And how are you just removing the OH group? बिल्कुल ऐसा नहीं होगा. This is not Barton reaction. How are you just removing the OH? This is not deoxygenation. So this is wrong. What about option number B? Option number B में क्या दिख रहा है? That there is a double bond formed over here. So by eliminating two hydrogens, you are not forming a double bond on this side. Position of the double bond is wrong. Option number C is your correct answer. And how does it go? एक बार जल्दी से लिख देते हैं इसको. What it is forming? The junction of the ring, it is trans junction. ठीक है? Trans junction. Let's say this is your oxygen. C double bond S. S methyl. Okay. Looking for a hydrogen from the same side like this. ये हो गया है. Once again to give elimination gives you product C, along with that COS and thiol like this. Okay, तो ये हो गया आपका correct answer. Very well guys, so we have once again done 7 questions today, and let me inform you guys that this is what we are doing in the reaction mechanism. In the reaction mechanism class हमने क्या क्या खत्म कर लिया है ऑलरेडी. SN1 रिएक्शन, SN2 रिएक्शन, NGP. This is what we have studied in the free class. E1, E2, E1CB, and along with that syn pyrolytic eliminations. And today we have done some really awesome examples of elimination. और next class में हम क्या करेंगे? Next class में हम करेंगे fragmentation. And all of this goes free to whoever who is interested in doing the class. बाकी आप नहीं करो तो आपका loss है. Right? And also let me inform you guys कि जो plus class है ना, वहाँ पे बहुत सारी अच्छी अच्छी चीजें आने वाली है. And in the reactive intermediates course we have already done carbocation and carboanion reaction, and we are very soon going to start radical and carbene chemistry. Okay, radical and carbene chemistry is going to start really soon. तो अगर आपको join करना है आप कर सकते हो. These are all the benefits of the plus classes. Okay, and if you want to join, don't forget to use the code Jagriti S Live. That gives you a 10% discount. And coordination तो चल ही रहा है. Do you send inorganic assignments too? Let me inform you one more thing guys, कि जो assignments है ना, that will be divided into two parts. The topics that I'm doing in the plus classes will be sent to the students who are there in the plus group, और जो free topics है जैसे special class में reaction mechanism है, so those topics will be sent to the in the free groups. Okay, so yes, in the plus classes we are doing inorganic chemistry right now, so definitely आपको inorganic chemistry के जाएंगे notes in the assignments in the plus group. Okay, yes, yes Mohit, definitely you're going to get very soon. All right guys, so if you are liking the content तो like share और subscribe कर दो. आपको पता है क्या करना है. ठीक है, I'll see you in the next class. चलो, bye everyone, have a nice evening all of you. See you very very soon.